Hello buddies, welcome back to Jigsaw Builds. Today we are starting from the square one, the very first piece of the puzzle. What is programming? Think about it. Every day you are using computers, mobile phones, and all kinds of gadgets to access apps. Education, banking, e-commerce, healthcare, and insurance, and every one of these industries run on computer applications. And computer applications are built using programming. So let's start piece together exactly what that means. Let's start simple. A program is a set of instructions that a computer executes, and a programming it is the process of creating those instructions. And every program must written in a programming language. That's the language we use to talk to the computers. Simple as that. But here's where it gets interesting. Since the first electronic computers were built in 1940s, one thing hasn't changed. No matter which programming language you write in, the computer ultimately understands only zeros and ones. That's called binary number system. A system with two digits 0 and 1. Compare that to what we normally use, a decimal number system 0 to 9 range. What humans or we use in every day. And there is octal number system and hexadecimal number system. You may now wonder how decimal numbers look in binary. So here's a visual representation of how a decimal number is represented in binary number system. So when you write 10, you may get confused whether it's binary or a decimal number. That's why we use bases like 10, 2, or 16 or 10 depending on which number system you represent. So when you type 10 as a normal number, deep inside the machine it is stored as 1010, the binary equivalent of the new decimal number 10. So the binary number is represented with a base 2 and the decimal number is represented with a base 10. The core part of the computer that execute every instruction is the CPU, Central Processing Unit, also called as the processor. Here's the catch. The processor can only execute machine language. Every instruction is given to it, it has to be written in the pattern of zeros and ones. For example, an instruction might look like this, a sequence of zeros and ones combined together. When you broken down, the first four digits of this instruction is what we called as op code, which represent the operation we are going to perform. In this case, 0001 will represent the operation add. So that means it conveys to the machine that we are going to perform an addition operation on the following operands. So this 8 sequence of zeros and ones will represent a number which is binary equivalent of a decimal number 4. Then the next sequence which is followed by this will represent the decimal equivalent of 5. So this sequence of zeros and ones simply convey that we are going to perform an addition operation on number 4 and 5 to the machine via machine code. That's machine language. Powerful for computers, but nearly impossible for humans to write comfortably. To make things little more human friendly, assembly language was introduced. Instead of writing raw bits, you write add 5, 4 and 5. Much easier to read, right? But the processor still can't understand this directly. It's need to be converted first. So the assembly language is passed by a tool called assembler that translates it into a bits of zeros and ones, make the CPU understand. The machine language and the assembly language are both called low-level languages because they are very close to how the hardware actually works. High-level language. This is where language like Fortran, C, C++, Java, and Python come in. These are called high-level language because they're closer to human language and much easier for us to understand and write. A fun fact, Fortran is, was the first high-level programming language ever created. So, but there is a catch. The CPU still doesn't understand C or Python directly. So how does your high-level language code eventually becomes zeros and ones? That's the job of compiler and an interpreter. A compiler takes your entire source code and converts it into an executable file with an extension of .exe. Once compiled, you can run that file directly. An interpreter doesn't create a separate file. Instead, it reads and executes your source code line by line, translating as it goes. Think of it like a compiler is like translating an entire book before handing it to you. An interpreter is like a translator standing next to you, translating each sentence as the speakers say it. One last piece of puzzle. Where does your program actually live and how does it run? Your source code is saved in a secondary memory, a non-volatile memory like an hard disk or an SSD. Non-volatile just means it doesn't get erased when the power turns off. When you run the program, it loaded from your secondary memory into a primary memory, RAM, which is faster but temporary. From RAM, the instructions are sent to the CPU for execution. And behind all of this, the operating system is the manager, coordinating the execution of every program running on your device. And that's the first piece of our programming puzzle. From what a program is, and all the way down to zeros and ones, and back up to the OS running your favorite app.